Is anyone else out there got any questions on this paper? Or we could switch to having all the three paper authors, if they want to turn their video on, and see if there are any general questions for all of them about SmartNICs. But that would be, if there are no more specific questions, then if people have I have a general question for all three of you, in case nobody else is going to ask one. I've actually got a lot of noise outside because in England right now they're celebrating Guy Fawkes Night. Actually, it's next week, so there are fireworks everywhere, which people from China will be familiar with fireworks a lot, but not this time of year. But in England, it's this time of year. Anyway, ignore the background sound. But my question is, for each of your cases, what would an ideal SmartNIC be? What would have made your life easier? You know, whether it was, LineFS, for file systems, or it was for transactions, or it was for, trying to optimize the code on the SmartNIC. So what would make it simpler for each of you? So anyone want to pitch in with an answer on that? That would be interesting, I think.
I see. So I have, I have a short answer, right? So I think the key problem currently is that, it's really, SmartNIC is very heterogeneous. If you look at the three papers in this session, they are all using different SmartNIC platforms, right? Zenith is using, Liquid IO, and LineFS is using Manual Bluefield, and we are using like National. So basically the biggest challenge is this kind of heterogeneity on the compiler, on hardware, and on the program language level, right? So I think one thing that could really make things easier is to have a a generic intermediate representation, that is shared by all the program models of different SmartNIC toolchains, so that we could program in the same language and then offload to different types of SmartNICs. And maybe there is like some local improvement and optimization that we could do. But the first step is really to have a generic language for that purpose.
Jong-il or Henry, any comments?
I think that's a great answer. And just to add one thing that's maybe fairly specific to our case, the sort of communication interface between the NIC and host memory is fairly limited. And in particular, with the Liquid IO, we have sort of access to packet queues and then just DMA reads and writes. And there is only so much you can do with those things. It would be nice to have, for example, atomic operations, or just in general, a more powerful programming model. And then the other thing is that I would, I guess, bring to other SmartNICs is that the Liquid IO has a low cost method of accessing host memory from the NIC. And that wasn't the case, for instance, with the Bluefield. So if that could be improved on some of the other platforms, I think that would also be good.
Great. So, John,
yeah, I also agree. It is high overhead communicating between SmartNIC and host. So, yeah, it will be great if there is a hardware technology that supports cache coherency between SmartNIC and host CPUs using the CXL. Yeah, in that case, we can offload more dynamically a bunch of host operations into SmartNIC. Yeah, I think that will be great.
So this is our shopping list to go back to all these folks. Okay, so there was a question from Edward Tremel.
Yeah, and it was actually just a question for the third paper that I didn't raise my hand in time. It was just about the generating those pairs of programs for your training data. I wasn't sure, did you have your generative model generate both the source and the compiled code, or did you generate the code and then compile it, run it through the actual compiler?
I see. Yeah, so during the data generation phase, right, what we do is that what we generate is like the source code for SmartNIC and the click, right? So it's in C++ and macro C. And what we do during the data generation is that we need to compile them into the compiler on the LLVM and on the SmartNIC side, and then that's how we do the training. But when you are doing the prediction, you don't have to do this again, right? You don't have to leverage the SmartNIC compiler anymore. So
Right. I know that your prediction was about predicting the compiler's behavior. I was
yeah.
just not sure, for the training, you actually ran the compiler on all of your generated synthetic examples.
Yes, that's kind of necessary.
Okay, great.
Cool. Of course, yes. So just going back to the generic question, of course, there's a cost to that. And that's one of the interesting things where you could just go back to having more cores on the main host. So then you have to worry about, what that, and that interface cost would be, would be potentially quite complex as well. On the other hand, accelerators, not just SmartNICs, as I mentioned, accelerators are sort of happening all the time in general. And so having a low latency, secure, high bandwidth between specialized processor, whether it's a NIC or it's some other thing, is sort of becoming something where, the various ways that we interface are probably reaching, the end of their lifetime, and somebody needs to do something a little bit better with, some cache coherence and some other high level programmability. So I think that's super interesting. So we're kind of out of time, and I think we're out of questions at that point. I don't see any other hands raised, and I think we got everything on Slack. So I'd just like to say, oh, there's a question from Aditya, sorry. I will, but do we have time for that? Sure, please go ahead.
Yeah, so you guys mentioned cache coherence for the SmartNICs. Would any of the work on CAPI, which is like a coherence protocol between between any generalized accelerator over PCIe that was developed by IBM, be useful here? I don't know if you guys have heard of that.
That sounds like a good reading list for people on their long flights back from the conference. Sorry, that was a joke there. The fact we don't have the long flights means you're more fresh and you have more reading time. Okay, thanks very much for really dealing with the Q&A. Thanks for all the questions from attendees. Thanks for the speakers. Great material. I think let's see what happens next year or the year after in SmartNICs. This is not going to stop happening. And what the choices are seem to be ongoing. So thanks again, and see you all, and maybe in the next session or later. Bye for now, and thanks.
I think the time's up for this paper. Let's have a mini panel discussion. So I believe all of the presenters are here, right? Okay. Thank you for your great talks. I enjoyed it. I have actually one common question to all of you. So you are here, you're working on different kind of applications, but you're here because you're using SmartNICs. So for your next project, SmartNIC project, what features do you want to add or improve to your SmartNICs? If you're say you're a SmartNIC vendor, right? What feature do you want to improve? Or so this is kind of things that that were kind of inconvenient for your current project. So can you say something about it? Anyone?
I can answer first if that's all right. I guess I don't know if what I want is the same as what the SmartNIC vendors want, but one thing that is limited about these SmartNIC devices is the memory access primitives and basically ways you can communicate between the NIC and the host. And it's really limited to basically packet queues and then read and write DMAs. But if there was any sort of atomic operations or something more advanced, like even cache coherence with host memory, that would be definitely give you more options to work with.
Great. Atomic operations. Yes, I like that.
Yeah.
Others? Or you're satisfied with your SmartNICs? That's fine.
Yeah, right. I also mentioned the cache coherency in the previous mirror. Other than that, one the bottleneck in our SmartNIC resource is a memory capacity, because we are treating a high throughput network, and the DRAM in the SmartNIC is used as a temporal buffer, but it only 16 gigabytes in BlueField-1 SmartNIC. So it is one possible bottleneck in the next generation of SmartNIC. So I want to increase the capacity of DRAM in SmartNIC. Yeah, that's the next.
It's getting better, right? Memory bandwidth is getting better, but I don't think it'll be as similar to the like CPU memory bandwidth, right? So
Yeah.
there is yeah. I mean, if it's a CPU, then it's going to be as expensive as CPU. So
Right.
and then also power consumption advantage will go away. So I think there is some trade-off here too.
Right.
Okay.
Yeah, I think so.
Yiming, do you have any comments to add? Or
I mean, I have some complementary comments. So I think common problem is that they should really try to make their SmartNICs easier to learn, right? Currently, the learning curve of SmartNIC offloading is actually very steep, right? So it's actually very difficult from the user's perspective to understand how to program SmartNIC and how to improve performance. So I would say that yeah, they should try to kind of flatten the learning curve. That's my expectation.
okay. So Jongil, you were out of time last time, right? So do you want to make some more comments on previous problems, or I think there was a person who raised the question, raised the hand, Jongil, I think. Yeah. So why don't you ask a question?
Hello, I'm Jongyu Park from Hongkyungan University. Can you hear me?
Yes.
Actually, I was gonna ask about why don't you guys do anything more similar to near data processing or something? But I realized I just read your paper. You guys do some compression or decompression also, to minimize the IO packets. Actually, I think that's really great. But I'm kind of curious if the SmartNIC computing power is enough for compression and decompression, or do you think stuff like FPGA or stuff like that could improve the performance? Or did you see any performance bottleneck of your approach in the experiments?
So your question is using the FPGA, we can improve more performance of compression and decompression?
Yeah. And I'm kind of curious, what is the performance bottleneck of your current design?
Right. For the compression and decompression, we use a spare SmartNIC cores because we without compression, about 60% of CPU cores are used to support DFS operations. So for the compression and decompression, CPU core is a bottleneck because we have to increase the number of cores to do compression because the throughput of compression is about 100 megabytes per second per one ARM core. So yeah, CPU is a bottleneck for the compression features.
Do you think any additional computing, dedicated computing units such as FPGA or ASICs or stuff like that could improve the performance?
Yeah, I think the additional accelerator can improve performance, especially for the compression and decompression. We may use GPU or other things. Yeah, it's possible.
If I have time, I want to also ask about I'm curious about the performance impact on core running applications when you use LineFS. Is there any? Did you see any performance drop or something?
I presented at the its result is in the at the last page of my presentation. LineFS also degrades the core running application, and it's up to I remember it's up to 49% in primary node and 19% in the replicas. that is the performance impact due to the interference with LineFS.
I'm also curious if then like what is the key component or key performance, like the reason why like the performance degradation? What is the key reason?
Right. So actually, we want to offload all the features into DFS operations, but there is one component, kernel worker, that does a simple data copy from persistent memory in the persistent memory. So it is better to it shows better performance with using the host kernel worker than just using the RDMA in SmartNIC side. So that is the main reason of performance degradation due to interference with LineFS.
Thank you so much.
Thank you.
Okay, is there any other questions? Otherwise, I think we can wrap up here. Thank you for the presentation, especially Henry, Yiming. I think it's late at night there, right? Thank you, Jongyu. You did a good job. Thank you. Let's